Okay, welcome. In this video, we're going to learn about how to draw Bohr-Rutherford diagrams and Lewis diagrams for both atoms and ions. So let's get right into it. So I've got an example here of an element from the periodic table. This is calcium. And you'll see on your periodic table, there's two numbers that we're concerned with. So there's the number at the bottom, which is 40.08. That is the atomic mass. And the number 20 is the atomic number. So using both of these numbers, we can draw the Bohr-Rutherford diagram for an atom, the Bohr-Rutherford diagram for an ion, the Lewis diagram for an atom, and a Lewis diagram for an ion. So we can draw four different diagrams based off of this one element. So let's see how to do that. So the first thing we have to do is figure out the number of protons, neutrons, and electrons from this information from our periodic table. The number of protons is equal to the atomic number, so it is going to be 20. The number of neutrons is equal to the atomic mass minus the atomic number, so 40.08 minus 20, which will be 20.08. Because this is the number of neutrons, we're going to round to 20, to the nearest whole number. And electrons. When we're talking about atoms, which we are in these first two scenarios, the number of protons is equal to the number of electrons. So the total number of electrons is equal to 20. So when you're drawing the Bohr-Rutherford diagram for the atom, you would have the number of protons in the center, as well as the number of neutrons in the center. So protons, neutrons in the center, and they all fit inside of the nucleus. And in the inside of the nucleus, you have the protons and the neutrons, but on the outside, you've got the electrons floating around in different shells. So we're going to draw our first shell, and in our first shell, you're going to see that there are two electrons. And you can fit 2 electrons in the first shell from our 20. In our second shell and every other shell after the first shell, you can fit 8. Okay, so I want to draw all 20 of these electrons onto this diagram. I've drawn 2 already. In my second shell, I can fit 8, and I'm going to draw all 8. The idea is that you try and get your circles as circular as possible. I'm trying. And you should too. So right now I've got 10. Remember, I have a total of 20. So I'm going to draw another shell to fit in another 8. So 1, 2, 3, 4, 5, 6, 7, 8. So in total, I've got 18 electrons right now, and I need to draw another 2 more. Now the next shell that I'm going to draw can fit up to 8, but I'm only going to draw 2. The reason I'm only going to draw 2 is because I only want to represent 20 electrons on this diagram. So this is how I draw my Bohr-Rutherford diagram for the atom of this element. If I'm drawing the Lewis diagram for the atom of this element, it's similar to this, but it's a lot simpler. So you just start off with drawing the element symbol in the center, which is calcium, Ca. And then you only have to draw the valence electrons. So these are the electrons that you find on the very outside. And, on the very outside shell. And on the very outside shell, we only have 2 electrons. So I'm going to draw those 2 right there. And that's it. And then for the Bohr-Rutherford diagrams for the ions. So let's talk about what happens for ions to form. When atoms lose or gain electrons, we form ions. Why do they do that? They want their very outside shell to be completely full. So if you take a look at the case for calcium here, it's got 2 on the very outside shell. And I mentioned earlier that it can fit up to 8. So it's got the option of either losing these 2, so that this can be its outermost shell, or gaining 6, so that its outside shell can be full. And we always want to go with the lower of the 2 numbers. So losing 2 is much easier than gaining 6. So that's exactly what the calcium atom is going to do in order to become an ion. It's going to lose the 2 electrons on the outside. Let me use a different color for the ions. I'm going to use gray. So I'm going to draw everything except for the 2 electrons on the very outside shell. I'm going to see if I have room here. So 1, 2, and then I have 2 different shells. So 3 shells in total. My first shell, I have 2 electrons. In my second shell, I've got 8. And in my third shell, I've got 8 as well. So I've drawn everything except for the very outside shell. And I'm going to need to designate that this is an ion and not the atom. So what I'm going to do is I'm going to use square brackets. And anytime you see square brackets, you know that we're looking at an ion. And we also have to show the charge. So we really have to understand this. So if you're losing 2 electrons, electrons are negative. If you lose 2 negative things, you have a positive charge, right? You're getting rid of 2 negative things, you have a charge of positive 2. Now, similarly, for the Lewis diagram, for the ion, we start off with the element symbol, and we did have the 2 electrons on the outside. But remember, when it became an ion, it chose to get rid of those 2. So we just draw our square brackets and write the charge of positive 2. And that's it. So this is how you draw all 4 of these diagrams for an element like calcium. Let's take a look at an element like oxygen. So here's the information there. I want you to maybe pause this video and draw all 4 of these, and then play the video again to see if you got it right. Okay, I'm going to take this up. So the number of protons, neutrons, and electrons is what we have to figure out first. Protons is 8. Neutrons, 16 minus 8 is equal to 8. And electrons, in the case of the atoms, is equal to the number of protons. Our Bohr-Rutherford diagram, you start off with 8 protons and 8 neutrons. In the first shell, you fit 2 electrons. And in my second shell, I can fit 8, but I'm only going to draw 6. That's because I want the total number of electrons to add up to 8. So I've drawn 6 electrons there. On the outside, plus the 2 on the inside gives you a total of 8 electrons. If I'm drawing the Lewis diagram for the atom, I'm going to draw only the electrons that are on the very outside shell. 1, 2, 3, 4, 5, 6. That's it. So there's my Bohr-Rutherford diagram for the atom, Bohr-Rutherford diagram, Lewis diagram for the atom. Let's do the Bohr-Rutherford diagram for the ion. So I'm going to draw the number of protons and the number of neutrons. And then let's take a look at what's happening on the very outside. I've got 6 electrons and I want a full 8. So my 2 options are to lose the 6 or gain 2. What I have to do is gain 2, right? Whichever one is the lower of the 2 numbers. Instead of losing 6, it's going to gain 2 electrons. So I'm going to draw everything exactly how I've drawn it, but this time it's going to have an extra 2 electrons on the outermost shell. So if you take a look here, by drawing the 2 electrons, my outside shell is full. Again, I have to designate that this is an ion with square brackets, and I have to write the charge. If I'm gaining 2 negative things, I'm going to have a charge of negative 2. Let's draw the Lewis diagram for the ion, starting off with the 6 valence electrons. Again, I want to gain 2 electrons in order for this to be full. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8. Right? When the 6 gains 2 electrons, this is a full shell. And because I'm actually gaining electrons, I would draw all of the electrons. And this has a charge of -2. So that's how you draw the Bohr-Rutherford diagram for the ion and the Lewis diagram for the ion. That's it.